we can look at trigonometric integration. I'm just going to take a quick look at the amount of slides we have left. Okay. So trigonometric integration, we basically, by understanding your trigonometric differentiation, you're definitely going to be benefited. The most common ones that you'll look forward to is the differentiation of cos x is negative sine x, and the differentiation of sine x is just cos x. So I think these rules that you can see right here might be in your formula sheet. Now these are just obviously the reversing of that process there. So we have sine x is equal to negative cos x, which is also, so if we differentiated negative sine x, we would say that is equal to cos x. And then remember, you always have to add your c. If we differentiated negative cos x, on the other hand, that would just be equal to negative sine x plus c. Because if we differentiate this, it becomes that. So look at these formulas. These are sort of, I think, the ones you get in your formula sheet, which aren't exceptionally helpful, considering there's just much more. Like this sign, and it only has an x inside of it. But for example, if you can derive, let's say we have cos 2x plus 1. If we derive that down, that would be negative 2 sine 2x plus 1. So that means, based on this being a very consistent process, we can also derive, let's say we had to derive negative 4 cos 4x, we would then find out that that is equal to negative sine 4x. So this is like a general, this is a situation with these trigonometric integration formulas that I would say just practicing and getting a more of a general understanding of like how these work. Like if you understood exactly like what I did here, you're probably completely fine. If you don't understand what I did here, then just practice. Just practice doing these questions. The best way I think to understand a lot of these questions, to get an intuitive like understanding on how to complete these like very simple, familiar, just integrate this questions, is to basically understand how to differentiate. And then if we can differentiate, we can probably reverse differentiate. We can anti-differentiate. So this is a more generalized formula here that is able to utilize using a linear function inside. But I think generally the formula would sort of look like, if we expect the differential of fx multiplied by sine with fx inside of it, that would be equal to minus cos fx. And that's our general understanding. And similarly, if we were looking at the differential of fx multiplied by cos fx, if we were getting the integral of that, we would see it would become sine, no negative here, fx. So that's our more generalized formula where we use fx. I don't know why I don't think they give it to you in the formula sheet. I don't know why. But it's sort of, to be honest, very similar to like when you have fx. When you derive that, you get the differential of fx out the front. And then you get fx. Cos and sine are a bit different. If you derive cos fx, you get you get the differential of fx out the front multiplied by negative sine fx. So it's very similar to this process here. These two processes are very similar. The only difference is cos becomes minus sine and sine becomes cos. And that's sort of the difference. But we do move this body that we have here inside cos out the front after differentiating it. So let's actually sort of apply that. we want to find the definite integral of some of these trigonometric functions. So let's start with the first one. So in this scenario, it's good to, like, even if you sort of have an understanding, it's good to look at the formula sheet, because you can immediately just apply a formula without having to worry about making any possible mistakes or misremembering something. So the formula sheet states that this would become negative cos x plus c. So we can just say, okay, this is negative cos x plus c. And we can ignore the c because we're doing definite integration. We have our 0 and our pi on 4 at the front. So then we can just substitute in values. So we can say this is equal to negative cos pi on 4 minus, because remember we always put a minus brackets out the front when we're substituting in the 0, cos 0. So that would be equal to negative cos over 4. We could be able to use our sort of magic triangles if we wanted to. I believe that would be equal to something like this. Minus, which means plus 1. So we have 1 plus this here, unless I'm misremembering. I haven't done trigonometry in a while. So that should be our value there. Now, with this one, we can just apply our formula. With sec, I think generally you're just going to apply a formula. They don't give you extra complicated ones. Generally, yeah, with sec, you're definitely going to apply a formula, I'd say. At least my experience last year doing exams, or the year before last year. So let's apply this formula. So this would be equal to, we have a definite integral, so we want to use those square brackets. Now we have it's playing up. We have tan x plus c, I think it was. Yep. And then we substitute in pi over 3 and 0. So that is equal to tan pi on 3. And we can, remember, you can add the c in. I don't think you get punished for it, but you don't need to add the c. And that's just a habit I have doing myself. Sometimes I can't rub it out, though. Whoa. Okay. We've lost something. Okay. Tan x. This is playing up a little bit. I'm going to try to rub everything out. Okay, that's a bit better. Whoa. Give me a second. It's just PowerPoint is not giving me a very good time. Okay. It's a problem with my computer probably. Okay, so that's equal to tan, and we're following the formula sheet here. Tan x, then we have the definite integral, so we have these two boundaries. So then we have tan pi on 3 minus tan 0, which is equal to tan pi on 3. Which I'm not going to bother apply the magic triangles immediately right now, because I don't think we have enough time to go deep into trigonometry. But at that point, you would apply your triangles to be able to find what sine pi on 3 over cos pi on 3 is equal to, if you wanted to simplify it down to get rid of sine and cos there. Which generally, like in an exam, you'd probably want to do if you're doing the definite integral, when they sort of want a very simple number for the area, generally. So this is the definite integral of 2 cos, and then in brackets 2x there. Now that's equal to negative sine 2x. And you can, you can postulate that, and then you can actually be able to check that by then differentiating this and making sure it equals the same thing when you go back to there. I'm having immense trouble with the pen behavior on this slide. So that would be minus sine 2x pi on 4, 0. Minus sine 0. We can't forget that. And our answer is negative sine pi on 2, which is equal to 0, I believe. Well, it's equal to negative 1, sorry.